Okay, welcome back. Let's start our second half of the afternoon. And our first speaker is Samantha Pollock from the University of Bristol, and she's going to talk about the significance of categoricity for formal theories and informal beliefs.
Okay, so what I want to do today is partly methodological and partly a work in progress. So I probably won't give you any satisfying conclusions about anything, but I'd be interested to hear what your ideas are with this work in progress. So I'll start off outlining a few notions that are relevant. And then we'll look at the literature to see what kind of significance people have attached to categoricity already. Then I'm going to outline, and this is the methodological part, outline a kind of framework for looking back at these claims and assessing them anew. So I'm going to distinguish between two kinds of significance that categoricity could have for us. And then the work in progress part is these open questions at the end. Okay, so we distinguish between formal and informal theories. So a formal theory is a set of sentences in a formal language plus a class of models that satisfy those sentences. So this is what Baldwin will call a full formal theory, in the sense that we're concerned with semantics as well. This is kind of obvious because we're talking about philosophical significance, and if we were purely concerned with syntax, we probably wouldn't get very much. And also because categoricity, as normally discussed, is a model theoretic property. On the other hand, an informal mathematical theory is just a collection of natural language propositions with a common mathematical subject matter. So this is kind of vague. I assume I don't have to say very much more about this. You can think of, say, PA2 as a formal theory and arithmetic as an informal theory. So propositions like there is no greatest number, say, will be one of the propositions in our informal theory of arithmetic. But I'm going to be concerned with a specific kind of formal theory, so formalization. This is a formal theory that's intended to formalize an informal theory. So a given formal theory might be a formalization and it might not be. It might just be a set of sentences that we play around with. But we're interested in the ones that are supposed to formalize our informal propositions. And obviously, there can be rival formalizations of an informal theory, and they can be better or worse than each other. So what does it mean for a formalization to be better or worse than another one? Well, first we'll specify some minimal requirements for a formalization. So the properties that a formal theory has to have to count as a formalization of an informal theory. And then on top of that, we'll have some theoretical virtues. So properties that are desirable for formalization. So, plenty of examples. Some of them are in competition with each other. And the one that we're interested in is categoricity. So, some people will say that categoricity is a theoretical virtue in this sense. A formalization of arithmetic is better than, if it's categorical, than a formalization that isn't. Okay, so a formal theory is categorical in the normal sense of the word. If all of the models that satisfy the set of sentences are isomorphic to each other. So the details, I've put some examples at the end. The details of them aren't really my concern today. But for example, no first order formal theory with an infinite domain can be categorical. on the other hand, PA2 with full semantics is categorical, but with restricted semantics is not. And so this shows up, again, why we include a choice of models in our formal theory. And ZF is not categorical, it's almost categorical. I propose that there's another notion of categoricity that people sometimes think about that's informal. It's not a model theoretic property, but it's more vague. And I'm not, this is where I start to get confused. So people informally parse categoricity in different ways. You might say it's just that every model in the theory is isomorphic to every other, and that seems like an informal version of the formal property we've just seen. Or you might say that a theory has just one model of isomorphism. So that seems to be an informal way of saying it has the property we've just seen and it's consistent. So I'm not sure if this is the right way of defining informal categoricity, and you might have suggestions that are better. But let's, for now, just say that an informal theory is informally categorical if and only if it could be instantiated by at most one structure. Or if we're going to go for the stronger version, the theory has just one model to isomorphism kind of thing, then we'll say that it is instantiated by exactly one structure. So I think there are some informal categoricity arguments already. And where they're interesting is where we have a formalization that isn't formally categorical or can't be, say, first order PA. But we want to show that somehow the same property can be assigned to the theory. And so we have to go by a different route, and often that's an informal route. Or we might want to show that set theory has this informal property of categoricity, but no, we can't use model theory like we do with, say, second order arithmetic. So that's the kind of thing that McGee and Martin do for set theory. Melia tries to do this for first order arithmetic, and Parsons and Halbach and Holson, if I have time, I'll talk about it at the end. I like to think of them as informal categoristic results, but Leon might disagree in questions. Okay, so these kind of arguments are made with respect to a particular informal theory, but it's always in consideration of a particular formalization. So it seems that categoricity, at least in the formal sense of the word, can't really have any philosophical significance unless we have a philosophical background already in place. And we already have some background in formal beliefs. So I think that there are two basic informal beliefs that we can have about a mathematical theory. One asserts some kind of existence, and the other asserts some kind of uniqueness. And the way that we combine these claims and qualify them gives rise to different kinds of realism about a theory. So, I mean, there are different kinds of each of these realism. I've just picked one for each. But say the ontological realist is going to build more into an existence claim. Semantic realist and the conceptual realist will be more specific about a uniqueness claim, probably, and the semantic realist might assert a uniqueness claim on the back of an existence claim. So they might think that the reason they might be semantic realists is because these truths are determined by the way the mathematical universe is, say. So, the details here don't really matter so much either. It's just, the point is just that if we're going to try and do any philosophy with categoricity, there needs to be some philosophy already in place. So here are some examples of what people have said about the significance of the model theoretic property of categoricity. So, Shapiro says, I conclude that a language and semantics of formalization should be sufficient to ensure communication. That is, the language of formalization should allow categorical characterization, and it follows that first-order axiomatizations are inadequate. So he's drawn some kind of significance for our axiomatizations from this property. Similarly, Meadows says that when we have a categorical formalization, we show that our axiomatic enterprise has been successful because we've isolated our intended structure. Walmsley and Martin make slightly different claims. So Walmsley thinks that a categoricity result will be of use. It's natural to think that a categoricity result will be of use to a realist concerning a mathematical subject whose language is naturally construed as having an intended interpretation. So he's pointing out that this result might have philosophical significance for our background beliefs rather than for our axiomatic enterprise. And Martin says that categoricity, Dedekind was well aware that categoricity by itself is worthless. Indeed, I believe that full determinateness of the concept of a natural number is the only legitimate justification for the assertion that the concept is instantiated. So again, the significance he's pointing to here is more philosophical than mathematical. So in general, by observing the existing literature, we see that there are, or there can be, two kinds of argument about the significance of categoricity. So what I call formal significance here is the kind of thing that Shapiro and Meadows were talking about. So this will be an argument for or against the claim that categoricity provides justification for or against a particular formalization of an informal theory. So the idea is that whether or not a formalization is categorical tells you something about the value of that formalization, whether it's a good one, whether it's better than another one, or worse. Informal significance is the kind of significance that Walmsley and Martin seem to be talking about. So that's for or against the claim that categoricity provides justification for or against particular informal beliefs. So given that I have a formalization that's a good one, I have some kind of independent reason to believe that it's a good formalization of my informal theory. That's going to make me think that it's faithful to my informal beliefs about the theory. You'd think that a good formalization is at least faithful to what I'm trying to express with the theory. And so, given that it's a good one and given that it's faithful, well, if it matches up with my informal beliefs that I already had, then it tells me that I was right all along to believe in whatever kind of existence or uniqueness claims I had. I hope that the difference between these two is clear. It might turn out that there's some kind of dependence between these kinds of arguments, so that you can't assert formal significance without asserting informal significance, or the other way around. And it might be that there's some kind of equilibrium that we need to reach. So it's kind of similar to, say, the case in philosophy of science. So theory, choice, or paradigm shift. How much of your theory do you want to give up on the basis of new observations, or how much of your new observations do you want to discount because they don't match the theory, say? So we have some informal reasoning on one hand, some formal work on from the other. And the properties of the formalisation are either going to tell you something about the value of that formalisation or about the correctness of the informal beliefs. So like I said, we can now categorise these quotes into those that are arguing about formal significance, namely Shapiro and Meadows, and those that are talking about informal significance, Walmsley and Hart. So just to hopefully make it a little bit clearer, this is the kind of picture that we end up with. So we have an informal theory that's made up of a load of propositions about the world, whether you think that contains mathematical truths, it also includes mathematical objects, whatever it is. The informal theory is supposed to latch onto that through these propositions. And we have informal beliefs about that informal theory, say semantic realism. And on the other hand, we have formal theories made up of sentences, which are satisfied by a lot of models, and those formal theories have formal properties, like categoricity. So we either hold on to these beliefs and kind of go around here in order to say that we've done a good job here with this formalisation. Or we already think we've done a good job here, we hold on to the formal theory and kind of go around this way in order to say, oh well, I was right, or I was wrong with my informal beliefs. So now that we have hopefully a clearer framework than we had before, we should be able to more clearly we should be asking for more explicit statements of the informal beliefs that are going on behind any argument about the philosophical significance of categoricity. But we should also be able to see more clearly where people are disagreeing with each other. If someone's arguing for formal significance of categoricity and someone is arguing against informal significance, then they kind of misunderstand each other. Okay, so then how do we assess the philosophical significance of categoricity? Well, it seems like what we do is find a formal property that is analogous to the informal belief that we have in mind. So something that would represent my belief and tell me if it turns up in a formalisation, either that my formalisation is good or that my belief was right. And we want to say that categoricity has formal significance if, given some belief about the informal theory, categoricity plays a role in telling you that the formalisation has justification in virtue of having this analogous formal property. So in virtue of formally recovering your informal beliefs. And it has informal significance if, given some independently justified formalisation, categoricity plays a role in telling you that your belief was justified in virtue of it appearing in the formalisation. So we want categoricity to be necessary and or sufficient for the formalisation, having the formal property that's like the formal analogue of our informal belief. So I'll just run through one example. I think, like Robert, I was also initially a bit over-optimistic about how much I'd be able to talk about today. So I'll just talk about semantic realism. So this is the informal belief that we have in mind. The analogous formal property, it seems, is that every sentence formulable in the language of the formalisation is given the same truth value in every model that satisfies the formalisation's set of sentences. It seems like that formally says the same thing as the semantic realist belief that every mathematical proposition of the right kind has a determinate truth value. Okay, so it turns out that categoricity in the model theoretic formal sense that we saw first is sufficient but not necessary for a formalization having this property. So for example, the theory of true first order arithmetic has elementarily equivalent models, which is to say that it has this property that we're looking for. But it's not categorical. And even though categoricity is sufficient for having this property, it seems like categoricity isn't really doing much of the work. It's semantic completeness that's doing the work. Categoricity gets you there, sure, but it doesn't. The link between categoricity in any case and this property is just not strong enough. And so it seems that categoricity has quite limited semantic significance. And this is of either kind. Either formal significance, telling us that formalization is a good one or a bad one, and informal significance, telling us whether we were right or wrong to be semantic realists in the first place. And so this is kind of like what I was just saying before. These arguments for or against formal or informal significance might go hand in hand. We might get there by the same means. And they might be dependent on each other. I'm not sure. But anyway, formal categoricity has limited significance for semantic realists, either formal or informal. And my tentative claim is that it also doesn't have much significance for any other kind of realist. The ontological realist isn't going to get very much out of it with respect to their chosen formalization or their belief in ontological realism. I'm sure at least some people here will disagree. And we can talk about that in questions, but I don't really have time to give any kind of justification for that right now. Okay, so now onto informal categoricity, which admittedly is a much vaguer notion, and so it's going to be harder to tell for sure how much formal or informal significance informal categoricity can have. But just like before, we think that it might tell us whether a formalization is a good one or a bad one. It might tell us whether our beliefs were right or wrong. It might seem that informal categoricity can't have any formal significance because it's not really a property of a formalization. But every argument that I've seen that seems to be about informal categoricity has a particular formalization in mind. So people seem to think that it could tell you something about your choice of formalization. So we'll assume, at least for now, that it's possible. So just like before, to investigate the philosophical significance of this property, we're going to want to choose a property. This time it's going to be an informal property that would count as good evidence for my informal belief about the theory being right. So it all works exactly the same, except that now we're looking for an informal property because it's only informal theories that can be informally categorical. Sorry, it's really confusing, and I meant to have a handout with all of these things on, but I forgot. Sorry. Okay, so again, I'll just take one example, and this really is where the work in progress is. So, suppose we're interested in conceptual realism, however construed. Basically that all of the TI concepts are objective. Well, it seems like a property that's at least sufficient for this belief being kind of justifiable, is that the informal theory is communicable or learnable. Like we can, when we talk to each other in the terms of the theory, we understand what each other are saying, and we can learn the theory. I'm quite confused about how this is going to work, but I said that I've mentioned Parsons, Pollock and Boston, which I'll do very quickly. So, the way that I read them, both of these arguments have something to do with the communicability or the learnability of theories, and they want to say something about how we can pick out a unique structure, or that our theory is about a unique structure, say. So, Halbach and Horson observe that we just do learn arithmetic. And Parsons is interested in showing what it would take for us to be able to communicate about arithmetic. And so there's at least potential there to say, by the way, they're both interested in paying. So there's at least potential to say, well, via this communicability or learnability, there can only be one structure that instantiates this theory. And so it's informally categorical, and so I was right all along, say, to be a conceptual realist. But admittedly, this is much less clear than the formal categoricity case. And there are lots more questions. So, is informal categoricity sufficient, necessary, or both for communicability or learnability? And more worryingly, is informal categoricity too close to our informal beliefs? Does it actually say anything different? So sometimes I think, well, it doesn't say as much as any form of realism. And then sometimes I worry that actually they're still a little bit too close together to draw any philosophical significance out of this. But I have to be interested to know what other people think. And I apologise for the lack of clarity. Yeah, I'm still trying to figure out what's going on. So just very, very brief summary, because I went through quite a lot. There can be two kinds of categoricity argument. So we might talk about formal categoricity, so that's the kind of categoricity that we're all familiar with, model theoretic property. But there at least could be a different kind of argument that's to do with a kind of informal version of this property. So, and it might help us to get around, it might help us to say, for example, that set theory is in some sense categorical, or first order arithmetic is in some sense categorical. And those are inherently interesting questions. There are two kinds of argument. I've claimed those about formal significance, so they tell you something about the value of your formalization, and those about informal significance, so they tell you something about the correctness or otherwise of your background beliefs. I've claimed without much justification, unfortunately, that formal categoricity arguments have limited significance of either kind. But there are more open questions about the notion of informal categoricity. There might be a bit more hope that we'll find some philosophical significance there. On the whole, we have a clearer view of what we're looking for, so where to look for significance. We don't want to be looking in the wrong places. And we have potentially a new and underexplored area to look at with respect to the significance of categoricity for formal theories and informal beliefs.
all too often people talk about arithmetic whenever they talk about philosophy and mathematics. But the most interesting mathematical theories, group theory, topology and so on, have axioms which are not categorical at all. I mean, you have finite groups, infinite groups, abelian groups, non-abelian groups. The same situation applies to topological spaces and so on. Now, my question is the following. You have mentioned the view that somehow the categoricity of a formal system works as a kind of justification for the adoption of that formal system.
Yeah.
My question is the following. Since most axiom systems of the most interesting mathematical theories are not categorical, what do you think the justification has been for devising these axiom systems?
Okay, so I obviously didn't make this clear enough that where are we interested? Where are we interested in cases where we already have a lot of background informal beliefs? So I take it that we don't have any background existence or uniqueness beliefs about groups, say. So in that case, it's not going to be, categoricity isn't going to, the lack of categoricity doesn't tell you anything, because it can only tell you something with respect to some informal beliefs that you already have about a theory.
Yeah, sorry, Rob.
Yeah, thanks very much for that, Sam. I was just wondering, I mean, when you flashed up, when you flashed up your notion of informal categoricity, I mean, the first thing that occurred to me was, oh, that's just false. Even the people who want to assert informal categoricity aren't going to say there is just one model. They're still going to want all the, little countable models, etc. But what does seem to be the case there is that people want to say, oh, there's one intended model. Right? So it's the notion of intended model that's doing a lot of work there. And if you look at things like the Martin argument, that's precisely doing that. You say, look, anything that doesn't satisfy these sort of mathematical considerations isn't the intended model because it doesn't meet that concept of set. So I was just wondering if you'd had any thoughts about that, or it's possibly a suggestion for future research.
It's a good point, actually.
Si sente bene, si sente.
Yeah, so that's a good point, because most of the people who make these informal arguments explicitly say right at the top, I'm only interested in uniqueness. I can't get any further than uniqueness. I'm not trying to say anything about existence. So that's like what you're saying. I mean, there's an intended interpretation, but I'm not saying that it exists, that one thing exists.
Yeah, I mean, you can certainly remain neutral on the question of whether or not there's an intended model independent of any. I mean, a nominalist can say, oh, there's an intended model rather than. Yeah, so it seems to me to be independent. But it's more just. One way you might cash out a distinction between formal and informal categoricity is formal is saying there is just one model, simpliciter, that satisfies these axioms, whereas informal is, well, maybe many models, but there's one that's intended.
Yeah, so that's exactly what Melia tries to say, even though he's talking about first order arithmetic. So you can't get rid of the non-standard models, but he can try.
Can you try using mine now?
Yeah, so he can't get rid of these non-standard models, but what he can do is try in some informal philosophical way to show that they're not as important. Or, actually what he does is try to show that second order versions don't handle the problem any better, right? They still have these non-standard models, and they're not any kind of less dangerous in that sense than they are for the first order. Does that answer?
Yeah, I'll
Okay, so we have 4 minutes and 2, now 3, probably not 2, but 2 questions. Matteo, you quickly yours. So Stuart and then.
that's a really nice framework you have set up. I wanted to ask you about cases where, well, the case I have in mind is like people like Pfefferman who want to argue that there is not a unique set of real numbers or the real analysis, right? And of course, he's well aware of the categoricity proof.
Yeah.
Just that he points out that it kind of begs the question in the crucial place. Like that is when you sort of in a crucial place, the categoricity proof, you're just assuming the very thing that, or like for continuum hypothesis is sort of his example. So we know from the second order that the continuum hypothesis is a consequence of second order set theory, logical consequence, right? Not categoricity, but categorical enough.
Yeah.
And yet he points out that the question's begged in the proof itself, right? That the framework in which you prove categoricity presupposes the very thing that and your framework actually sets that up pretty nicely because, as you said, you can go here or here. You sort of have these nice equivalences, and then you either do a modus ponens or a modus tollens.
Yeah.
So it's kind of hard to see sort of how anyone's getting any argument.
Yeah. So he could have. The algebraicist about say arithmetic could just say, well, my informal belief is that there is no uniqueness, and so since second order arithmetic is categorical, well then that's a bad formalization. You can just pick another one. But you're right in saying that he could say something else.
Right. The case of arithmetic is kind of like a straw man. I mean, I guess there are skeptics, and of course they're nominalists, but we're not addressing them right now. But there are skeptics, I suppose. But I think most people just take that first order arithmetic, arithmetic is fine. But its analysis is really where there's some real interesting debate.
Yeah.
And yet the whole framework there is still fits. I mean, we do have categoricity of second order analysis and so on.
Yeah, but I guess if you want to argue, I mean, in my framework, if you want to argue for or against significance categoricity, you kind of have to already accept that it's an acceptable move. So he's just outside of my framework because he doesn't accept the first stage, which is that categoricity is acceptable. Yeah.
But he has a reason that he thinks the question's begged. So I think your framework, it's still the right one.
Oh, good.
And he doesn't deny the categoricity proof.
Okay.
He doesn't think there's a mistake made anywhere.
We have time for a 20-second question and 20-second answer.
Yeah. You rightly said that you can have completeness without categoricity. I'm thinking of the example of the theory of true first-order arithmetic, which is complete but not categorical.
Yeah.
But precisely in cases like that, isn't the definition of that set of sentences, the sentences of true first-order arithmetic, isn't that basically based on the idea those are the first-order sentences which are entailed by the categorical theory of second-order arithmetic? So, I mean, how do you understand arithmetical truth if you don't understand categoricity?
Okay, I think my quick 20-second answer is going to be to hold my hands up and say I picked a bad example to show that categoricity isn't necessary for having that property. I could have picked another, but the point is the same, that you don't have to have categoricity to have justification for thinking you should be a semantic realist.
Okay, let's thank our speaker.